The main documentation for the module is available on my website under post to orthotropic.com, under post data wrangling. I try to keep it up to date, so by the time you see it may have changed a little bit, but not in any major fashion. So what I'd like to do first is just to do a little bit of a refresh after the introduction you've had to the RStudio IDE with a couple of things to reinforce. So number one, you've noticed I've started a new session. My version of R is the last version available. My environment is empty, very important. Never start with an old session when you work on a brand new document. It's always a good practice. You may avoid mistakes of using variables or functions that were defined previously in your environment and are not in your files. It will avoid you lots of problems when you knit document, markdown documents. Another thing to do, which is a good practice, is every time you start, I do it daily at least, go under tools and make sure that your installed packages are up to date. For those of you who are just starting with R, remember you install the package once. Once it's installed, you just load it either through library call or require call. You do not need to reinstall it. So if you need a new package in your R Markdown document and you have installed packages, make sure you comment it out afterward. So where we're going to start first is quick refresh, and I'm going to use this document here. It's a bit easier to see until I get into the details of programming. So I'd like to come back to why we're using this, why we're using a framework of data science. In most functions or jobs in the world of finance, whether you're in risk management, an analyst, a lot of the job consists in data manipulation. So the best practice to do is ensure you get extremely good at it. That way you can spend a lot more time on analysis. The other aspect of using such softwares, whether it's R or Python, it achieves the same thing in the end. It's a mean to an end, is to ensure that you can work at large scale. So whenever you write codes, as you'll see, your code really doesn't change when you want to update. What changes is the data that you feed into it. So whether you update the same analysis on the same financial data, or you want to switch financial data, for example, going from one industry to another, you don't need to change all your code for it. So the first thing, in terms of refresher, I'll skip very quickly over it. It's very good practice. You'll see all throughout the notes. Every time I call a function, it always has the package name, semicolon, semicolon, function name. Now, why do I do this? Now, there are a couple of reasons. At this stage in your learning, it's very important, I believe, to do so. It actually embeds in your memory which functions belongs to which package. So it starts building some form of mental organizations of the environment that you're playing with in your mind. It also has advantages as you become more advanced. First, it reduces errors a lot. The best example to see it is when if you load library tidyverse from a fresh session, what you see is that a number of functions are masked, meaning that the same function name belongs to different packages that are installed in your environment. Now, why does it matter? It matters a lot because when you call a function without specifying the package of the specific function you want, you leave it up to R to decide which functions of which packages. A good example would be with the filter and lag functions. So if I just go in a help function and with lag, you see fairly quickly when you do a help call on it that there are 3 different lag functions in 3 different packages. So it's very important to call the right one. You may notice that if you look at the one from stats, for example, requires as an input a vector matrix or a time series data, whereas if you go for dplyr, it will actually operate on different types of values. So at times that may cause conflicts. The filter function is one of them, where personally when dplyr came out many years ago, I had a lot of trouble with it simply because I was not coding properly by not putting dplyr, semicolon, semicolon, and lag function. So that's one example, and as you become more and more advanced, if you want to publish a package, eventually it's required for CRAN standard to be able to publish the package. Now, another aspect we've discussed, it's always good when you think about any functions that you use or any coding that you do, that there are kind of three components. There's always a data input, a transform or a function that you use to transform or operate on the data, and the function will return an output. So why is this important? It's important in terms of trying to understand the workflow. So first, if you have an input, what type of data is the input? Compare that to the transform or the function you want to use, and is that the right type of input that a function expects? And then finally, what type of output the function outputs as a result of the transformation that it does. So that kind of workflow is very important. It would help you a lot in terms of being able to manipulate data and perform operation and reduce a lot the number of mistakes you make. Now, one note on debugging, I cannot mention it often enough. It's always the first thing we do when we see error messages is panic a little bit. Now, debugging is an important aspect of the learning process. It occurs with absolute beginners, intermediates, and very advanced programmers. Fortunately, R is extremely good at providing some guidance around what could be wrong, only if you calm down and spend the time to actually read versus panicking. So something that you're going to need to learn to like debugging. Quite often you'll notice that you may spend 90% of your time on debugging and 10% on actually writing 90% of the code. This is just part of the way it goes, and as you learn and you get better, it becomes easier. Now, I'm going to skip a little bit on the operators and arrays, since we covered that in a class or workshop. The one I want to bring your attention to, simply because it's if you operate in a real world with their data set from whether like Morningstar commodities, which we use in this class, Reuters, DataStream, Bloomberg, any of the data vendors, what you'll find is that quite often when you deal with continuous futures contracts, they would have ticker names. For example, for WTI contracts, CL beta contract code, and you may have the first contract being 001 and then month, and the second contract would be CL002. So what you want to ensure is that when you write a code to extract multiple tickers, let's say you want the first 12 contracts, you want to write this very succinctly. You don't necessarily want to type all the names of it. So the function sprint f in R is extremely useful to achieve that. So if you could look at a help function, what I've done here is provide a simple example. If, for example, you wanted to write ABC and then 08, 09, 10, 11, you could actually do it all in one go with that. If you wanted to write, let's say CL, which we had from the first contract to a year out, you could actually write it this way. And because it's a paste command, you could add anything you want in between. So you can actually do in one very short script, having a series of 100 or 200 or 50 different tickers without changing too much in the code. So that's a very useful function. I'd like to come back to one aspect on that I find very important and often missing, especially at the beginning stages. Most of us are used to operate in an Excel world, meaning that we have a visual canvas of a worksheet. So it's a bit easier mentally. I find it very useful to start from a canvas and then transition to R as a way to make things easier and to adapt in your brain around the new workflow. So what I've done here is I've just put a simple NPV computation from an Excel spreadsheet, and what we're going to do is to replicate it in a process, learn some skills. So the first thing we need to do, if we think, is we need to recreate this, which is where everything is computed. So effectively in this case, we have an NPV of 5 cash flows, yearly cash flows. The cash flows are $1 million each, and we need to somehow compute the discount rates. Here that would be in each Excel cell, by having equal and discount function, and finally the NPV, which is simply the product of the discount rate times the cash flow. And obviously the NPV of the project is the sum of the NPV column. So we've done that in Excel, assumed an interest rate of 5%. Now, first thing we do is to create a table or data frame with 2 columns. So we have 1 column time to maturity from 1 to 5 and cash flows 1 million per year. So if we actually define this here, we end up creating the first part of our data frame or table in Excel. Now, that's not the most efficient way of doing it. There's a much simpler way by recreating this way. So if I reprint what we have, it's the same thing that we have, with the exception that now we've just repeated the cash flow of 1 million 5 times, and we have a sequence from 1 to 5 in terms of years. You've noticed here the scientific notation. It is something that you can turn off if you want in R. Sometimes it's useful, sometimes it's not that useful, especially if you want to print in a document that other people are going to read. But for the sake of this tutorial, that's good enough for what we do. Now, adding computation to it is we're going to use a mutate statement, and we'll cover it a little bit in the next section in more details. But before we do so, we need to define our interest rate as a variable. So if I defined interest rate as a value here, as a variable 5%, what you notice is now in my environment, I now have the interest rate of 5%, and I've got a data frame which we have. So what we want to do is to add then the next column, a discount rate. Now we do so here, assuming yearly compounding, same formulas you would put in Excel. So mutate statement from a library dplyr or tidyverse allows us to add a column to an existing data frame. So in this case, we're interested in adding 2 different columns, so 1 discount rate, and once we have the discount rate, we can add the NPV column at the end. You'll notice here that I do not need to do it twice, so I do not need to mutate by adding discount rate and then adding the NPV afterward. I can do it all at once. So in this case, when I compute NPV and I use discount rate here, it uses what has been described in the prior line. Now, a quick thing to do is generally when I code, I prefer to define what I want, iterate with it, and once I'm comfortable with it, then reassign it. It's a much easier way than defining it and then checking it and then coming back and doing it afterward. And finally, what we want in this case at the end is using the sum function from base R, sum the column NPV. So we do so, as you recall, by having the data frame df and NPV. You've noticed I will iterate back and forth between using some of the tidy and base R functions. I'm a big fan of the tidyverse library overall. There are cases you see throughout data frame where it does the same thing. It does it very elegantly, but sometimes it's the fastest way to do it. Other times it's not. So in this case, all I'm going to do is rerun, take the sum. The NPV of the project is $4 million. It matches exactly what we have in Excel. Now, if you wanted to embed some logic, introduction to if statements, this one is very similar to Excel, so same as the if function in Excel called if else. Again, I would recommend all the time to go in the help function, check exactly how to use a function, and if you don't know after reading it, use the examples below. So in this case, same concept of Excel. We have a condition. In this case, if the NPV is positive, print great project, and if it's negative, then print bad project. So in this case, it's a great project simply because the NPV is positive. And next, we're going to move into the tidyverse aspect of it by trying to import data. In the first example, we'll import data from the web, Excel files. We can also do it directly through APIs, which we'll see later, which is the favorite way of importing data in the world of analytics and trading data science. So first, I'm going to clean my environment. Good practice, start from fresh. Now, if you notice, when you clean your environment, you clean all variables, functions that were defined, but you're actually not starting from scratch in terms of libraries that you've loaded already. In this example, I'm going to reload them again, but you see you will not have any messages that normally pop up when you load for the first time those libraries. So we're going to need 3 libraries in this case. Tidyverse, which is always the main one, and it loads multiple packages. Luridate for date management, and also read Excel, because we're going to read an Excel file directly from internet. Now, before I start with the actual coding itself, a good way to do this would be by using the import dataset and figuring out what we were trying to do. If we're trying to import from Excel, you can select the Excel that you see here. You could browse, if you have a local file, you could browse directly into your file folders and import data locally. We're fairly lazy generally in the world of data science, trying to minimize the work that we do. In this case, the file is available from internet, and bear in mind that the file is updated probably monthly. So we don't want to download it manually, save it, we want to go direct. So if I run this the next time, it will run from the latest file. So the way to do this is you can actually copy the actual address. In this case, it's going to be from Excel. Under File or URL, we can just paste the URL we have, updating. And then it actually shows us the imported file. And we could use this to actually customize our import. So in this case, we have a number of things. It does not look very good. And that's generally the case for most Excel files on internet. That's a drawback of working with Excel on internet instead of APIs or professional data services, which are already cleaned up. So in this case, first thing to notice, we've got a number of extra rows here. We have like four extra rows that we want to skip. So by skipping the rows, the next thing is we've got I think I'm going to skip 5 rows in this case, because what we want is the first rows as names. So if I skip 5, now we have our first rows as names. So this data from Freddie Mac shows the prices of houses across all US states by month from 1975. So looking at this, you can see there are a couple of more things that we need to look at that are incorrect. The first one, we can start cleaning right at source. So in this case, the date is shown in a weird format. So we're going to leave this as is for now and then use some data wrangling and parsing tools to convert that to a specific date. Then for some reason, Arkansas shows as character. Now one note on how this ends up showing. In Excel or R or other softwares, generally when you use a GUI for this, the GUI effectively looks at the number of rows, probably the first 1,000 rows, the first 100 rows, and makes a determination as to what type of data that is based on what it sees. So in this case, you can see numbers the same as others, but that's probably because further down the file, there are some characters instead of numbers. So that's probably an indication that the end of the file is probably dirty as well in terms of data. So in this case, if we switch this to numeric data, or numeric or double, we do the same, and we can keep going. In this case, what I'm going to do is I use this just to show you how to use it. Generally what I do is I would look at this and do the minimum and then copy and paste. You could choose to press the import button and it would actually run everything in your console. In this case, I will not do it here. And here's the reason. In this specific case, because we've got so many columns across all the states, we've got probably about 50 columns for states plus 1 for the date. And if you look at the way it actually does it here, by using the GUI, it actually, the moment you touch one, every column is specified. Now, generally speaking, I prefer not doing this. I'll show you how we do it. I start by downloading from here. It's the same command as you'll see in the import. I start by creating a destination file. So what the destination file is the name of the file that you want to save after you download it. The command to download it is from the curl library. You've noticed here I put curl, semicolon, semicolon, curl download, but I don't have a library curl that I loaded. The beauty with mentioning the package name, semicolon, semicolon, the function name, is if you're only using one function and it's already installed, you do not need to load it. It will fetch it. In this case, what curl will do is fetch this file from this internet address and then write it locally, wherever is my working directory, as this file name. So if I run both, you've seen the file now is being downloaded over here, and from there I can just run the same command as we had. The distinction being that I know it's 5 rows I want to skip in this case. That's the file I want to read, and instead of having so many columns, I just specify that the first column, which is the date, is a text, and then repeat 52 times the numeric. So this does the same thing as the long command we had. So if I load it, now we have state API. Now, whenever we load data from internet, always ensure that you actually look at data. The biggest mistake that we make is to load too quickly, not noticing that there are probably dirty data, either additional rows at the end, additional rows at the top, or additional column on the right. And then when we try to perform transformation data, it does not work. So first thing you look at, you can use different ways, different commands. If I double click on it, you'll see types view. You can visually inspect and even filter, if you wanted to, your data the same way as you would do in Excel. Another way to look at this is just to look at the top. So head will actually print the first rows of your data frame, and tail will print the bottom rows. Now, why do we do this? Tail is important. So what I mentioned earlier, so there are probably excess rows at the bottom, which are fairly dirty. So what I'm going to do here is just print the whole data frame, show the last 20 rows, and you can see in this case that the data is indeed incorrect at the bottom, simply because they add totals and subtotals. That is very common in Excel. So what I'm going to do is I want to omit all the rows that contained NAs. Now, when you use any omit from the stats package, what you have to think about is it will remove the entire row even if only one column has NA. So you have to be very careful to know exactly what you want to keep. You may have some missing data for some states, and if you have one state that's missing data, it will remove the entire month for all. So if in this case, if I run again and look at the bottom of my data frame, now it looks fine. So I've got the last month I've got is July 2020, which makes sense given that we're in early September. I'm not sure when data gets released, but it makes sense in terms of timing. A couple of useful tricks to analyze the data as well would be using dplyr slice. So a slice effectively either removes data from your data frame, and the slice is by row numbers, or it selects some. So in this case, if you wanted to see just the first 5 rows of it, it's the same thing as doing head on it, or the same thing as doing head df5. You would see the same thing in terms of data. So that's one example where you could choose to use either the tidyverse language or base R. It all depends on how it flows into your script. So there's nothing wrong or nothing bad. It achieves the same thing. You could use the dplyr slice underscore head, which does the same thing, or slice underscore tail by specifying the number of rows that you want to see either at the beginning or at the end. I talked a little bit about mutate earlier. So in the dplyr world, when you want to modify columns, there are 2 commands that are very useful. So mutate will add a column at the end and still return all the existing columns. Transmute will only return the columns that you specify in the statement. So as an example here, and it will deal with dates. So what we're going to do in this case is try to transform the first column, but before we do so, I want to bring your attention to so date management in R is one of the most important skills We won't cover it in details in this short video. We don't have time to cover the entire R for Data Science book, so I try to focus on what's relevant for what we're going to do later with the material. There's an excellent summary provided by Berkeley University at this address, so you can click the hyperlink and go there. Key thing I would mention at this stage is when we have a date, in this case we defined, let's say, a variable d as something that looks like a date. Now, what do we type when I find out the data type is str? That shows that I've got a value d here, which is a character, and it looks like a date, but it's a character. Now, if you want to transform this into a date, we can use the asDate function. The input would be the character that we want to transform into a date, and the format. Now, this is where it gets useful to look at the key formats. Generally, I have a preference for using the year, month, and date. Why? Simply because whenever you want to order or save files or types of operation, it's always in the right order. Whereas if you write it with month, day, or a year at the end, it's all over the place. So it's much cleaner to use this way. In this case, what's relevant is we've got a character format, which is 4-digit year. So 4-digit year here would be capital Y, separated by a character. And then we've got the month. Now the month in decimal, 2 decimals, is small m. And then we've got the day. The day is small d. So if we convert that and call it dd, now what we've got, if we look, you've seen it's been added to my environment, but you can see there's no bracket in between. So that's an indication that it's something else than a character. Let's confirm it. Now we've got a date. So in this case, what we're going to do is looking at our data frame that we extracted. We have a column month, which has this weird format. So what we can do in this case is by using lubridate function ymd, year, month, date, to transform this column in this format with the parse datetime function. I'll let you on your own go through the function for help. But what happens if I run this now? Where's the transformation? So remember, I use mutate in this case. Mutate will add it back at the end. So if in this case, we look at this date, so that's January 1975, do we see this at the end? Yeah, so we see 1st of Jan 1975, so that's correct. Now if I just do transmute, in this case, it only returns the date. Now one very useful feature of dplyr or tidyverse for manipulating large data frames like this one, lots of columns, not always easy to visualize, is to be able to reorder the column by using the select statement. So a select statement with a data frame as an input allows us to select specific columns, either to remove some using a minus sign, or to reorder what we already have. So in this case, we'll do both. So what we ran that command already, if I just remove month from it, you see the first column is gone now, and month is not there anymore, and we still have the date at the end. So what we'd like to do is to move this back, move the date at the front, and I do this by reordering, by putting the date column in the front, and rather than specifying all the columns, you can use the everything function, which reorders all. So if I run this, now we've got something that makes sense. Next thing to look at would be if we want to reorder them by descending order. So rather than starting from 1975, starting with the most recent, we could use the dplyr arrange function. Arrange is like sort, and in this case, I want to sort it descending order by the column date. So if we run this, we would have it in the right order. Rename is also an important one. If you write long scripts with potentially changing data inputs in terms of column names, you may want to use that function. I use it very regularly. So in this case, if you wanted to rename the date column with period instead, you could just rename it and it would move to period. Separate is one that's extremely useful, especially if you do a lot of data parsing with complex name. I use it a lot with web scraping. You've got internet addresses for data which contains a lot of character strings. Once you understand the structure of it, being able to use separate is extremely useful to split it into different columns. So in this case, if I wanted to, for example, split the date column into a year column, a month column, and a day column, I would use a separate function. So input is the date column of the DF data frame. I want to split it into a year column, a month column, and a day column. The separation is characters, which makes sense. We want to split into 3, and there's 2. That's 3 results. We convert and remove those, and if I run it, I would actually now have more columns. You notice the original one is still there. You can choose to remove it or not with a select statement. Now, if I try to recap all this, I've gone through in details to show you what various functions do, but it's fairly short. If I just recap everything that we've done, I can actually do it all in just 6 lines of code. So if I run this, I've got my data frame. Now, always inspect before you think you're done if there's anything else in it that you think might not be extremely easy. So in this case, what I'd like to draw your attention to is you could go into the data frame and check it all. So if I first start with the rows, everything is good at the front, everything's good at the back of it. I look at the column, we've got the states. Now what you could do as a final check is if you look at all the columns you've got, you may find that, I think I've cleaned up already, but in this case, there's a US at the very end. Now, it's not a very good idea to have spaces and long names in column names. So what I would do in this case is try to change that one and change it in a way that I don't have to specify the specific name of the column because I know it's the last column of what comes in. If for some reason they decide to change the name of it, I do not want to hard code that in my code. So the way I can do that is by leveraging extracting the column names. If I want to extract the column names, I could use the names function and data frame the input, and I can see in this case it's the last one that I want. So when I say I want to rename to US, and the way I do this is by selecting the last observation, which is this one. The way to do that would be by using the dplyr last will return the last value. So even if, for example, they were to add more territories or states, it does not matter. It will know exactly by positioning. So by renaming it this way, I could reprint df, go to the end, and now we've got US. Now another little trick that is very useful in this case, if you try to write as little as possible in your program, you see that define it here, and then I redo it again. What you can do is to wrap your statement that you defined by another set of brackets, and it will actually print it as well automatically without having to retype it afterward. So you see this a little bit later in my workshop class notes. Now moving on to the tidy data types, that's one aspect which is fairly difficult at the beginning. What I'd like to bring you to as a visual explanation is way better. There's an excellent one that's provided on a Tidy Explain website that's visual. So the concepts of long and wide data frame. A wide data frame is the same as a table in Excel where you would have dates for each rows, and then as all your variables are by columns. So a good way to explain what a wide and a long data frame is through this website, the Tidy Explain. So what you have as a wide data frame is exactly as we have in an Excel world, where we've got, let's say, ID here would be the date, so 1975 January, 1975 February, Alaska, Arkansas, and whichever state we have, and then you would have the data in the body of the table. When we work with large data sets, we prefer working with long data frames. It's much more efficient. So what we want to do is to convert that data structure into a long data structure where we have the date, we would have the state over here, and we'd have the value. So if you look at this to where they are, so 1975 January, 1975 February for the first state, and then you would repeat for each state. This allows us to perform a lot of operations without specifically mentioning the name of the state. And that's kind of what we're about to do here. So the way to convert, so what we have at the left here is a wide data frame. Looks like an Excel spreadsheet. We want to convert this, and we can make use of the pivot longer function from tidyr. So tidyr is part of the tidyverse package. The way we do this is when we convert from wide to long, we have to specify our index, which is the ID in this case. So that would be the column date. Note the minus in front. It will not work without the minus. It indicates the index. And then we want to specify the name here that we want for the actual variables. We want to name this a state. We can name it different things. I'll show you an example in a second. And we want to write the values to HPI. Now, as a note, in this example, I've used the same as what the underlying data means, so state and house price index. Generally, as a practice, I would have date, series, and value, which means that I can write a lot of code afterward in a very generic fashion, knowing what it is. If there's a need at the end to change the column name, you can always do it using the rename function. So if I run this here to pivot it, you'll see that now it's transformed into a long data frame. If you wanted to reconvert it into a wide data frame, you could use the tidyr function pivot wider instead of pivot longer. And in this case, what you're specifying is that in order to convert back, take the names from the variable state, and that becomes all your rows, and then the values that you want to put over here in your core data is going to be the house price index. So if you were to just print it here, you'll notice I'm not assigning it. We convert it back to exactly what it was. So in this case, to go further in the tutorial, we're going to stick with a long data frame. I've named it dflong just to avoid confusion. Now the next thing in terms of being useful is the ability to filter. Now filtering visually can be done as I've shown earlier using the view. So if you were to look at dflong here, you can go into filter and then select, let's say, so far we've discussed the world of tidy data. There's also another universe in the R world that uses different types of data. It's very important that you're familiar with both. They have pros and cons, and I use both depending on the situation, albeit I prefer working in the tidyverse world in general. So what is an XTS object? So an XTS object is an extensible time series. In terms of the way it looks very similar. It would look like a wide data frame. The difference being that the date column is actually an index, is not a column itself. And the body of the data we have, in this case the values or the HPI, is what part of the core data of the data frame or of the object. Best to look to an example again. So the TimeTK library allows us to convert very easily, smoothly from one type to the other and vice versa. So we're going to start with where we left, which was our dflong. So if I look at our long data frame, we need to convert back to a wide data frame in order to convert to XTS. So we'll convert pivot wider to return back to our original series we had. So it looks that way. So that's the data frame with data as being column. Next, we're just to be sure, we omit any NAs. There should not be NA at this point in time, but just in case. And we can use the tk_xts function from the TimeTK package to convert from data frame to XTS. As I mentioned, an XTS object needs an index. The index is generally a date format or a time format. So we need to specify which variable in our wide data frame is the index. In this case, it's our date column. So we just say date_var equals date. Once we run that, we can look at the output of it. So it looks fairly similar. In this case, I just printed the first few rows of it. What I'd like to bring your attention to here is, again, using the command str, if we have our a standard data frame, I can put any of them here, just a date long. So you can see the structure would be a data frame with 3 variables. If I do the same on an XTS object, we see that the structure itself is fairly different. What we have is an index of class date and then data, numeric data in it. So what we can do to see what it is by loading the library XTS, or XTS is built on Zoo. Extracting the index, we see we have dates here as character, and core data is going to be everything else in data frame. We can convert back, so the reverse of tk underscore XTS is a tk underscore table, TBL, for data frame. If we revert it back to a table or data frame and print it, it's back to exactly where we were. Now, the reason we cover this is, especially in the world of equities and portfolio management, there are a number of excellent libraries or packages in R to perform operations. So one of them is Performance Analytics. I highly encourage you to have a look at the package vignette. The documentation is excellent, but it all works in XTS. One way to port some of the functions in Performance Analytics in terms of tidy data is to use the tidyquant library. So the reminder of the tutorial deals with APIs and packages and data input. So there are various packages that it's important to be aware of for the types of work that we're going to do going forward. One of them, I encourage you to look online. I know it's available on CRAN as well. This is a development version, but the package RTL, all in large cap, is a package I co-developed with the co-founder of RPanda. It's live now. It's specialized in commodities, but also provides an API for Morningstar commodities for subscribers, which we'll be using in class. We'll be covering a lot more of it later when we get to analytics. So one of the packages, so we've used tidyquant earlier in the world of getting data for equities. QuantMod is in the XTS universe of data. It's an excellent library. It allows us to download directly from various sources, like primarily Yahoo Finance in terms of stock prices. So if I load the library and I select the symbols, again here I'm selecting an array of symbols. I don't need to run it for every symbol. I would have and use the QuantMod get symbols. Now, see what's happening here. That's one of the drawbacks that is very difficult to work with a larger set of data with QuantMod, is when I run this function, 2 things occur. One is it downloads the data, historical data from 2004 for each ticker, but it assigns the tickers directly with the ticker names. So that makes it a bit more difficult to perform operations like we did before on average stock price and so on. What I suggest is to leverage the great work of QuantMod, but you can use it through tidyquant, which effectively uses it. So tidyquant library, by looking at the tqget options, this gives you a sense of the types of data can be extracted with one package from different sources. So if you want stock prices, it's stock.prices that we would use as get, the get argument. Another one which you use a lot would be so from FRED, the St. Louis Federal Reserves provides lots of economic data. So if you wanted to extract data from FRED, we would be using the tickers that you can find from the FRED website on the APIs, but you would specify get economic data. Similarly, QuantDL is another one that is very useful, and a lot of other ones, so it's beyond this tutorial to cover them all. So we use the tidyquant tqget function to get the same thing as we had. So stock prices, because they're stock prices from Yahoo Finance. In this case, I put a different date because I don't want as much data. And 2, in this case, the 2 function is very interesting to use. I would highly recommend not to hard code it. In this case, by looking at tqget, you notice that it expects dates as character in terms of the arguments on the from, so it's always a character argument. So in this case, what we do is by using the base R sysdate, it returns the current date, and we can convert it to character by wrapping it into as character. And whenever we run our script, it will always give us data that's up to date. So if I run this over here, now we see that we have all the data set the same as we had like with this data set. But two things occur, like one, it's in one data frame that's conducive to performing a lot of operations like we did earlier, summarize the data set and value. It's in one data frame. And most importantly, one thing you notice with XTS or QuantMod is all the column titles have the ticker name dot and then open, high, low, close. Again, that's something that's easy to go around, but it's just something that you can get away with by moving straight from into a tidy format. In this case, what we have is all the data for the S&P and then all the data for Amazon, which are at the end of it. So if I were to do tail here of data, we would see Amazon data. So that brings in all the power of QuantMod into a tidy environment. So I discussed about thread earlier. The same thing here occurs. You can use get symbol with source equal thread. In this case, I'm trying to get the US CPI information. If I download it, same thing occur. It appears in my environment as a separate variable, which I then need to call with a specific name, or I can call it using tidyquant, and I could add many symbols if I want to add different types of inflation measures. Another one we use a lot in finance would be extracting interest rate data. We can use tidyquant tqget because it's from Fred in this case. We would use economic data as a source, in this case from 2000. You've noticed here I've started to use a little bit what we discussed earlier in class about using paste command. If you go on a Fred website, if I go here for, in this case I know the symbol already. I just want to show the website, and you can search on the website for what you want. Once you search what you want, the symbol is this piece here on it. So what I want is to build a yield curve and be able to plot it later on. So the yield curve would start with 1 month rate, 3 month rate, 6 month rate, and then it's a different code for bonds. So by wrapping this into a paste statement, I can extract all the codes that I need. You notice they're not every single year, they're based on some of the benchmark bonds. So by putting this all into one go, I'm extracting all these series from Fred economic data into an object called data. I'll use any on it as usual to clean my data, and from there we can see now we get a long data frame with all the data in similar structure than what we discussed earlier, which leads me to an introduction to charting. Now there are two main worlds of charting. I will not opine for one or the other. I personally use both of them. Both of them have pros and cons. So Tidyverse, ggplot2, and Plotly. Plotly covers some dynamic charts, but it's extremely easy to work with ggplot and then just output it into a Plotly object as well. Those of you in my data science class will be spending a whole class on visualization. So one aspect I highly recommend, whether you work in Plotly or ggplot, is to read the Grammar of Graphic from Hadley Wickham. It provides a very good introduction to the layer structure of charts. Whichever package it is, they all work very similarly in that sense. So the way to do that with ggplot is to output a long data frame. ggplot expects a long data frame. And from there, we actually provide an aesthetic. So if I just go into a ggplot function, the arguments be data, since we piped it here, so that's the first argument we don't need to mention. Then we need to put aesthetics. So aesthetics, in this case, in its most simplistic form, that's where you specify what column goes into the x-axis, what column goes into the y-axis. And if you have multiple symbols or series, you can use the argument call for color to split it into different colors. It's easy to visualize which one is what. So the first part of ggplot, in this case, would actually plot an empty chart with the data. So when we talked about the layers of graphics and the grammar of graphic, we first create the plot and then tell the plot that we want a line type plot. So in this case, what I have is a time series for each of the actual data points we have, whether they are short-term instruments or long-term instruments or bonds. And the way to add more information to it, you can use plus labs, specifying the title, subtitle, captions, and then even formatting your axis. So that's a very, very basic plot that we have here in ggplot. If we wanted to turn the same into a Plotly environment with a Plotly library, which you can install separately, I will load it here. We would feed the same data, except here the syntax looks slightly different. You've noticed the tilde to indicate the variables. Same concepts, we pipe our long data frame into the base Plotly function, indicating x is the date, y in this case I want to divide by 100 since it's a percentage. The names would be the symbols and the color would be the symbols, and I want a line chart. So if I'll put it this way. Disregard the frame widget argument. It's just to make it render on internet, on a website. In this case, if I were to plot x, what we just plotted, we now have the same chart, except that it's interactive. So we can actually filter on some portions of the data set we want. So this is just an example. It's not the pre-edit chart, obviously not the most effective at communicating, but it's just an introduction to the world of plotting. Next, in terms of data that we'll use a lot in our classes, and I'll skimp very quickly over this one because we'll come back to it in a lot more detail in further sessions, is using the EIE package, so the US Energy Information Administration. Now, this is one of the best sources for data in terms of quality and timeliness. It does require an API key to work properly. In this case, I have not loaded my API key, and I don't say want to disclose it online, so I will not run it. But what we have to do in this case is by going on the EIE website. Let's go to the API. What we can do is select which data set we want or which time series through this. If I go into petroleum, for example, summary, find this position. So there's a tremendous amount of data on this one. If you know what you want already, it's a bit easier. So in this case, going through this API, I found that the series I want, the series ID, is this name here. So in this specific case, I chose a different one. What I want to plot are the stock prices, stock levels for WTI crude at Cushing and natural gas for the lower 48 states. The series ID on the EIA were this and this. And I can actually extract it all in the same way directly. You could use the EIE data package, or there's a function in RTL that makes it way easier. So that's the EIE to tidy in the RTL package. It converts everything into a data frame, and it actually names, it will rename this weird series ID with what you want to name it. So in this case, I've loaded RTL already. I'm not sure it is. Let's see. So you would see how to use it simply with an example, the same way as what we had over here. So in this case, I put the title without spaces because that's normally how we do it. It's easier to manipulate afterward. And if you were to run this, it would return all the data in the data frame. QuantDL works the same way, so I will not necessarily go into it because of time. However, if you go on their website for R, as the same thing, same concept here. You can use the tqget function search with your API key, and you can use the timeTK package as well to convert back, so entirely quant. So I provided a few ways to do it here. So that is the way I would recommend. So when I mentioned earlier, when we want to extract, let's say the first 6 futures contracts for WTI, I would just generate an array that generates all the codes from 1 to 6. You've noticed in this case there's no trading zeros. Trading zeros might be problematic simply because the order of which in your data frame might go from 1, 11, 2, 20, and so on. So by having the leading zeros, it always helps. In this case, we actually use further transformation using the gsub function to find that pattern in the symbols and replace it with an empty space. So all I end up with would be the CL1, CL2, CL3, CL4. Now US Treasuries, in terms of the zero curve, is another thing that we use quite a bit in finance for discounting. We'd use that. In this case, we'd use the same thing as what we did. So it's a repeat of the what we had, just a slightly different iteration. Using the tqget function. In this case, get is QuantDL as a source from 2015. So we define the argument here. What is it we want as ticker? Pipe it as the first argument of tqget. That would give us effectively a zero curve from 1 year all the way to the end of the curve by day that is published. We'd want to perform an any omit, and because we don't need the symbol over here, we already have it in this table, we just clean it up by removing the column symbol and then pivot into a long data frame. So if I run it, we now have a long data frame of interest rates, and we can use the gplot function to replot it in the same manner as what we had earlier, but now we have a lot more. Morningstar is one of the leading data providers, one that we use exclusively in class simply because it's an awesome package that provides direct access to an API without the need for an install on Windows locally to work. So it integrates perfectly with Data Science World. So what we do, and I'll do this separately in class because it requires credentials and paid subscriptions, and it's not something for a video. However, if you are interested, I would highly encourage you to look at the RTL package. So there are a number of functions. I'll show a few that you can actually use. So get price. So you see in this case, get price is part of 2 libraries. So we want the one for RTL. That will show you how to extract directly from the API in a seamless workflow using your user ID and password as credentials. And it's actually coded already for a number of data tables that they have. If you want to extract more than one, you can use the get prices function. This one, and the other one that's fairly useful is the get curves. If you wanted, as of a given day or as a time history, get the full forward curve of various futures contracts, so you could extract in one go just using that. So with that in mind, thank you very much for the time, and hopefully we'll see you in class and workshop shortly.